Hello, welcome to the fourth lesson in the A-Level Coasts unit. Today we'll be looking at erosional processes. Some of them you'll be familiar with, some of them you'll not be familiar with. So just go with it, okay? Some of them are quite similar to the processes you studied at GCSE, and we're just going to go into them in a little bit more detail. If you've got any questions regarding anything we go through, just drop me a message either via email or on Google Classroom. Okay, so on here I've put a box of loads of different words of coastal processes. Just have a look at them, see how many you're familiar with, how many you can define, and yeah, just to sort of get your head in the right space. So before we talk about the different types of erosion, I just thought I'd define what erosion was for you. So nice and simply, erosion is the degradation of rock and its removal to expose a fresh rock face. Now the key part here is the removal part. Now rock is degraded by a whole range of things, but not many of those things will actually be able to remove the rock fully from that area. And that's what erosion does. So in the picture you can see you've got the nice fresh cliff face saying finally I'm free, after all those years have been stuck behind other rock. Now the rock you can see at the bottom, that will eventually be carried away by the sea, moved to other parts of the sediment cell and deposited somewhere else, and you can see evidence of that if you look at the sea. The sea is a murky brown colour which matches the cliffs, not surprisingly, because it will be full of nice material from the cliffs that it's moving, transporting, and the fact it's got so much sediment in it, we can say that it is a high energy destructive coastline. But you knew that already. So we're going to look at 6 types of marine erosion. The first of which is an old favourite, hydraulic action. So anything hydraulic is to do with air and air pressure. So once you know that, you can kind of work out what happens. Now in order for hydraulic action to happen, you need a cliff with horizontally aligned rocks where you can see the faults in them. Now if you look in the picture, just to the left of where the wave's breaking, you can see the cliff, and you can see it's got horizontal faults all along it. It looks like it's made up of loads of different layers. And what will happen is when the wave hits, air in that gap will be forced inwards in what's called wedging, because the air acts like a wedge being forced into the rock, breaking it apart. Now those faults will grow bigger and bigger and bigger over time, until eventually the bit of rock will be under so much pressure that it will break off. And what happens each time the wave hits, it forces that air in, which builds up the pressure, makes the crack bigger. But whilst the wave's there, the piece of rock is still being held in place. When the wave goes backwards, the pressure is released, and then the rock will be weakened and can collapse. So hydraulic action is similar to GCSE with just the addition of the term wedging in there. So in answers, try and use those two terms together if you can, hydraulic action and wedging. Erosion type number 2 is cavitation. Now this occurs every time a wave hits a cliff face. So when the wave hits the cliff, the pressure inside the gap in the rock builds up, because basically the air is being forced into the crack, a bit like when you blow up a balloon, you force air into the balloon, and that air is then under high pressure because it's trapped inside there, it can't go anywhere. When the wave goes back, the pressure is released, and that causes a fizzing of the gas within the water. And that's kind of like when you shake up a fizzy drink bottle or can, you build up the pressure in it, and then when you open it, you release the pressure and it fizzes everywhere, and it's that fizzing action inside the gaps in the rock that break the rock down on a very, very, very tiny level, but still this contributes to coastal erosion. So cavitation, big wave hits, forces the air in, the air becomes pressurized. When the wave recedes, the air escapes and the pressure causes it to fizz. So cavitation is just fizzing of the gas inside the water, and that fizzes away at the rock on a very small scale. Type number 3 is corrosion, or abrasion you might call it. This is exactly the same as at GCSE. So the waves, they've got a lot of energy, they can carry a lot of sediment. When a wave hits the coastline and breaks, the sediment it's carrying is thrown and will chip away at any cliffs, any surfaces in the way. So you can see in the picture on the right hand side there, the wave's got a slight discoloration to it. That's because all the sediment it's carrying. So it won't just be water that hits you, it will be water plus stones, plus pebbles, plus grit, plus sands, plus seashells, plus anything else it's carrying, driftwood, whatever else. If you've ever been in a car that's sort of, say, driving along Torquay seafront and gets hit by a wave, or you've been on the bus, afterwards you'll have lots of sand, lots of sediment left on and around your car, and that's why if you walk along a coastline after a storm, after a big series of destructive waves, there's often like sand and pebbles scattered all over the path and stuff like that, quite away from the sea, and that's because of abrasion. So type number 4 is called quarrying. Now this is where a destructive wave hits the cliff with such pressure that the vibrations from the wave will travel through the cliff and dislodge parts of it, usually the lower parts of the cliff face. So you can see in the picture on the right hand side, you've got a cliff that is very fragmented. It almost looks like some sort of giant's Jenga tower stacked up there. Lots of different bits of rock all stacked on top of one another, and if a big wave hits it, eventually the vibrations could cause these pieces to break off. This picture actually really does show how fragmented different rock faces can be. It almost looks like someone's just stacked those up there. So in this picture you'll also get hydraulic action due to the amount of cracks and gaps there are in the rock. You'll also get some cavitation happening there, and the result of that will be when the pieces break off, they'll be susceptible to abrasion. So you'll get lots of different types of erosion occurring in one place. Erosion type number 5 is corrosion, or you might have known this as solution. So some rocks, due to their chemical composition, are a lot more vulnerable to being dissolved by seawater. Particularly chalk cliffs are very susceptible to this. Similar to acid rain, but it's more the pH of the seawater that will dissolve it. So what happens is, as the rock gets dissolved, it changes, it gets dissolved away, and then the little tiny particles will get carried off by the seawater. So this, obviously, with things we've looked at like the chemical composition of seawater changing with ocean acidification, things like this will be happening a lot more. But a little link you could put in here is between the solution or corrosion rates along a coastline and the amount of CO2 going into the oceans. There's a good correlation, a good link you could bring in between those two. Also, with sea level rise, more of the cliffs are going to be available to the sea, and therefore more of the cliffs are going to be vulnerable to all these types of erosion. So a really good link between any rates of erosion change is sea level rise and ocean acidification. And the sixth type of marine erosion is attrition. Now, hopefully you'll be familiar with this from GCSE. So attrition, you can see the picture on the right hand side there is a really good example of a beach and sediment that is experiencing attrition. So attrition is when the pebbles are carried by the water, they hit against one another, they get smaller, they get smoother, they get rounder. And if you look at the image, you can actually say, well, that beach is experiencing a lot of attrition because those pebbles, they're not made that smooth. They've been smoothed by being rubbed over the different pebbles within the seawater. So we've got attrition is the sixth one. Just remember as well that all of the erosion types can happen in the same place. Obviously, sometimes all of them will be happening at once. If you've got, say, a big storm coming in, if you've got a high energy coastline, for example, but equally this could happen in a low energy coastline. You might get a big freak event where you get this suddenly happening. So yeah, this week as well, if you're listening to this, I'm recording this on the 11th of May. It's actually quite stormy in Torbay, so there's some very big waves going on, so we'll be experiencing a lot more of these processes as opposed to days when the sea's flat and you'll almost get no hydraulic action, things like that happening. So there's a lot of factors. If you think about the lessons we've talked about so far, we've talked about energy sources. So where's the energy coming from? How much energy is there in a system? And that's in flux all the time, it's changing all the time. So when you're thinking about erosion, you can't see it now as an independent, oh, this coastline has hydraulic action 24/7. No, it doesn't. It will be changing all the time, going up, going down, and depending on other factors. Obviously, coastal defences come into play here, because if you've got an area experiencing these, chances are you might want to protect it if you've got people living anywhere near it. Of course you might not. There might be no one living there and it might just be an area that can be afforded. So just really try throughout this unit to develop your links to everything we're studying. So based on 6 different types of erosion, what I'd like you to do is just create an annotated diagram, or a series of diagrams, like a storyboard if you want, to show how each process happens. Now there's 6 of them, so I'm not expecting like pages and pages and pages, maybe just a couple of diagrams for each one with some good labels on them, showing what's going on nice and clearly. And then once you've done that, I want you to think about which processes will be affected the most by climate change and sea level rise. So are we going to see a massive rise in solution? Are we going to see a tiny little rise in abrasion, that sort of thing? So think about each of them, maybe put together 2 or 3 thoughts for each of the 6 processes. You might be thinking, oh, Tom's asking us to do a lot today, but this PowerPoint is only 9 slides, including this one and the title one, so it's not too much. Like I said, if you've got any problems where you're struggling, just get in touch with me, drop me an email and I'll give you some help. I'm not expecting works of art, though I know some of you are really, really good. So if you're thinking, oh, I can't draw, just some simple square block diagrams are absolutely fine. Okay, good luck with that. Send me a picture of your work when you're done, submit it on Google Classrooms or email it to me, whichever's easier. Okay, I hope you have a good week. I'll be posting another video on maybe Wednesday or Thursday, so keep an eye out for that one. Okay, stay safe guys, thank you.